Everybody, this is Mr. McNair, and this is going to be a short video. Well, not really that short. It's going to be a video on lessons 4.6 and 4.5. Just so that you know, we're going to do lesson 4.6 first, and then we'll do 4.5, just because I think that it works better in that order. So what I want you to do real quick, go ahead and pause the video, and I want you to try these two warm-up problems on your own. I want you to go ahead and find the y-intercept. Alright, now after you've done that, the process of going through this problem that we found out was that if you're trying to find the y-intercept, we know that the y-intercept has a 0 for the x. So if you were using the cover-up method, technically you can cover up the x value and you can get the y-intercept. So here we would know that the y-intercept in problem number 1 is 2, or the ordered pair 0, 2. Okay? And then we can do the same thing over here in problem number 2. If you cover up the x value, we can see that the y-intercept is negative 8. So that's the ordered pair 0, negative 8. Okay? Alright, here we go. 4.6. Don't forget to go ahead and write down the title and the date. Now we're going to do this first problem on together. So here we see that we want to graph the line with a slope of negative 2 and a y-intercept of 4. Okay, so the slope is negative 2 and the y-intercept is 4. Well, let's graph the part about the y-intercept first. Okay, we're going to talk about that first. Alright, so if the y-intercept is 4, that means that's the point right here. Now if the slope is negative 2, that means that's the same thing as negative 2 over 1, right? And we know slope is our rise over our run. So from this 4, that means that we can rise negative 2. Well, rising negative 2 means go down 2, 1, 2. And then running positive 1 is to the right 1. And then from that point, this point right here, we can make other points. We can go again down 2, right 1. Down 2, right 1. Or even from this, we know that negative 2 over 1 is the same thing as positive 2 over negative 1. So we could have also went up 2, left 1. So this point also would have been on our graph. Alright, and then from there, we would go ahead and connect the dots. So we connect the dots here, and that would be our line. Okay? Don't forget to put little arrows there. Alright, go ahead and pause the video and try this one on your own. Alright, after you've tried this on your own, let's go ahead and do this together. So we see that we have a y-intercept of 1. So that is right here. And from that y-intercept of 1, we're going to graph our slope. Always, always, always start with your y-intercept first. So we know our slope is negative 2/3. Once again, that's our rise over our run. So from 1, from this point here, we're going to go a rise of negative 2, which once again is down 2. And then a run of positive 3, which is to the right 3. 1, 2, 3. Alright, and we can go from this point again, we can make more points. Down 2, right 3. So there's that point there. Now remember, negative 2/3, a negative 2 over a positive 3 is the same thing as a positive 2 over what? Negative 3. So we could have started from this point and also went up 2, and then a run of negative 3 would mean go to the left 3. 1, 2, 3. Up 2, left 3. Alright, now it is extremely important that you know how to do both ways, because sometimes it'll be more convenient to go one way versus the other. So make sure that you know how to go both ways from your y-intercept. Alright, let's move on. Slope-intercept form. I've heard many of you guys talk about what slope-intercept form is. And slope-intercept form really is the formula y equals mx plus b. That's slope-intercept form. In slope-intercept form, we know m stands for what? M stands for the slope. We know b is the y-intercept. B is the y-intercept. Okay? Remember the problems that we did in example 1 and 2? Where we started on the graph was the y-intercept. That's going to be called b. All right? So here, this problem says write the equation that describes the line in slope-intercept form. Here we have a slope of 1/3 and a y-intercept of 6. Okay, so once again, we know that our slope-intercept formula, is y equals mx plus b. And we're going to plug in our m. We know our slope, is 1/3. So y equals m, which is 1/3, x, have to attach that x. Your slope is always going to be attached to an x variable. Plus b. Well, what's b? Well, b is 6. That's our y-intercept. Okay, so plus 6. And there you go. We're in slope-intercept form. Y equals m slope x plus b. All right, let's try another one. So here we have a slope of 0 and a y-intercept of -5. Go ahead and pause the video for a second and just write this equation out. All right, after you've tried that on your own, we once again know that slope-intercept formula is y equals mx plus b. So we have our m, our slope is m. So y equals m, and here m is 0, x plus our y-intercept. Our y-intercept is -5, so we could go plus -5. Now, most of the time this plus negative, I don't want to see it. I'd rather not see plus -5. Plus -5 is the same thing as doing what? Yeah, exactly. It's just a -5. So instead of plus -5, let's just write -5. All right, now let's simplify this a little bit. What is 0 times x? Yeah, 0 times anything is what? 0. So this kind of cancels itself out. So we really don't even need that there. Okay? That's not even necessary. You know what? Let's just do that. I'll just keep it there. So let's just rewrite it. So since that cancels out, this is y equals, that's gone, -5. All right. And this actually, remember, this makes sense because this is going to be a horizontal line. And it's going to have no rise with it. It's just a straight horizontal line. All right, let's go ahead and do this problem. Write the equation that describes the line in slope-intercept form. All right, we'll do this one together. All right, you don't necessarily need to copy down the graph, but let's just kind of work through this problem. All right, so we know that the slope-intercept formula is y equals mx plus b. So the two values that we need are the slope and the y-intercept. Can you look at this problem and tell me what the y-intercept is? Let's do that part first. Can we tell what the y-intercept is? Yeah, it crosses the y-axis at this point right here, at 1. So the y-intercept is 1. Can we tell what the slope is? Well, remember, slope is rise over run. So if I'm going between these 2 points, then we went up 1, 2. So we went up 2 over 1. So our slope is 2. So since our slope is 2, our equation is y equals m. We said m was 2. Don't forget your x. Plus b. We said b was 1. So this is our equation in slope-intercept form. All right, try this one on your own. All right, now after you've paused the video, once again, we know that our slope-intercept formula is y equals mx plus b. So once again, I like to find my b first. All right, so just looking at this graph, can we tell what the b is? Well, yeah, the b is right here. Now, it's not specifically plotted, but we do see that the y-intercept crosses that y-axis at that point. And what is that point? 3. So we know that the y-intercept is 3. And then from there, can we find our slope? Once again, slope is rise over run. So from this point to this point, we went up 1, over to the right 2. So our slope is 1/2. So once again, plugging into slope-intercept form, mx plus b, we're just going to write y equals, well, what's m? 1/2. Then we put down our x plus b, and b was 3. So this is our equation for that line in slope-intercept form. All right, let's move on. Example 5, write the equation that describes the line in slope-intercept form. Here we have a slope of 4, and we see that 2, 5 is on the line. Okay? So, go ahead and write this problem down. We're going to do this together. So here, we know that our slope-intercept form is y equals mx plus b, right? Well, this is the thing about this problem. Do we know what the slope is? Yes. It's 4. Do we know what the b is? No, we don't. This point doesn't give us the b. That's just a point on the line. This is some random x and y. Some random one. But from here, we do know that an example of the y is 5. An example of the x is 2. And we know that the slope is 4. So we could plug these values into this equation and then solve for b. So that'll look like this. This y right here is 5. So 5 equals m. M is 4. An example of our x is 2. Plus b, well, we don't know what b is. So let's go ahead and solve this. Can we simplify this equation? Yeah, what's 4 times 2? 8. How do we solve for b? Because once again, that's what we're trying to find. Well, we subtract 8 from both sides. And we see that 5 minus 8 is -3. Those canceled out. And we have b. So now we know what the slope is and the y-intercept. So let's plug that into our slope-intercept form. Y equals m, which is at 4, x plus b. b was -3. So this here is our equation for that line. Now, a very common question is, Mr. McNair, how come we didn't plug in the point 2, 5 over here? Well, remember how at the beginning I said that 2, 5 is an example of a point on this line? Okay, there's infinite points on a line, right? Infinite. This is just one of them. So we keep this y and the x in there as variables since we want to represent every point on the line. Okay? Cool. Let's move on. Try this one on your own. Alright, after you try this on your own, let's plug it in. So y equals mx plus b. They want it in slope-intercept form. So once again, we know what the slope is. We know an example of x and y. That's one example of the infinite points on x on this line. So we could plug all these values in because they didn't give us the b. So y, in this problem, we're going to use 1, equals m, which is 8, times x, an example of x is -3, plus b, we don't know. All right, let's simplify. 8 times -3, well, that's -24, plus b. How do we solve for b? Well, we're going to add 24 to both sides. So we see that 25 equals b. So now we know that the slope is 8 and the y-intercept is 25. So our equation, y equals m is 8, x plus b. So this is our equation that describes the line in slope-intercept form. All right, let's move on. Steps for graphing in slope-intercept form. There's a few of these. You might need to pause the video after each step so that people can write them down. Definitely write these in your notes. So, step number 1. If the equation is not in slope-intercept form, put it in slope-intercept form, which means get y by itself. The question is y alone? Is y isolated? So before we graph in slope-intercept form, y needs to be alone. Step 2, plot the y-intercept on the y-axis. Now this is extremely important. The y-intercept It's called the y-intercept because it's on the y-axis. So please make sure that you plot it on the y-axis. Remember, the y-axis is the vertical one. Plot it on the y-axis. All right, next step. Create other points using your slope, your rise over your run. And remember, you're going to be starting from, whoops, you're going to be starting, you're going to be starting from your y-axis, your y-intercept. So create other points using your slope from the y-intercept. Okay? And then after that, you're going to use a ruler and connect the dots. Use a ruler and connect the dots. All right, let's go ahead and try an example of this. So, going through our steps, graph using slope-intercept form, y equals negative 2/3 x minus 1. We'll do this one together. So, the first question is y by itself? Is it? Yes, y is alone on this side. We don't have anything else on that side but y. So y is isolated. So the next step, if we go back to our steps, was to plot the y-intercept on the y-axis. Well, what's the y-intercept? Well, y equals mx plus b. We can see that the y-intercept in this problem is negative 1. We see that the slope is negative 2/3. So, once again, the second step was plot the y-intercept on the y-axis. Okay? So, let's do that. Y-intercept is negative 1. So, here's negative 1 on the y-axis. The third step was to create more points using your slope. Now, the slope is negative 2/3. Remember, slope is rise over run. So, we're going to rise negative 2, so go down 2. And then run positive 3, which means go to the right 3. 1, 2, 3. And then from this point, we can still make more points. We can go down 2, right 3. So there we go. Also, please remember, extremely important, once again, negative 2/3 is the same thing as what? Positive 2 over negative 3. So from this point, I could have also went where? Well, positive 2. That means go up 2. Negative 3, that means go to the left 3. And then again, from that point, we can still go up to left 3. All right, and then once again, we're going to connect our dots with a ruler. And don't forget to draw your arrows at the end, because the line goes on and on forever in both directions. Now, when you create a line, how many points do you need to make a line? 2. Now, whenever you make a line in slope-intercept form, now once again, this is just for slope-intercept form. When you make a line in slope-intercept form, I want at least 3 points. 2 points make a line. However, a third point pretty much confirms that line. Okay? All right. I want you to pause the video and try this one on your own. All right. After you pause the video, here we go. Let's try this one together. Is y by itself? No, so let's get y by itself. How do I get y isolated? Well, first thing we need to move is this 2x. It's a positive 2x, so we subtract it from both sides. So these cancel out on the left, leaving you with negative 5y equals negative 2x minus 25. Is y by itself yet? No, this negative 5 is there, so we need to get rid of that. It's being multiplied, so we divide everything by negative 5. So on the left, these negative 5s cancel out, leaving you with just y. Negative 2 divided by negative 5, well, we know a negative over a negative makes a positive, so that's positive 2/5 x. And then once again, a negative over a negative makes a positive. So negative 25 over negative 5 is positive 5. So we have a y-intercept of what? 5, and the slope of 2/5. So we got our y by itself. Now, the second step after getting y by itself is to plot the y-intercept on the y-axis. So our y-intercept was 5. So let's go ahead and plot that on the y-axis. Here it is up here. And then from there, we're going to do our slope. We said our slope was 2/5. So 2/5 is up to right 5. But notice that that takes us off our graph. Okay, and this is one of the reasons why it's important to know the different ways that you can use your slope. Now, we know that a slope of 2/5 is the same thing as what? -2 over -5. Because remember, a negative over a negative makes a positive. So from this 5, our y-intercept, we could have also went a rise of -2, so down 2, and then a run of -5, which is to the left 5. All right. Now, I know I told you that I want at least 3 points. This one, we ran out of room. There's no other rooms on the graph. So we're going to have to suffice with just those two. So we're going to connect the dots. Don't forget to put arrows at the end of your lines, because once again, a line goes on and forever in both directions. All right, here we go. 4.5, direct variation. Two things have direct variation if they are related in a way such that the ratio of their values always remains the same. All right, write that down, please. All right, what's under these boxes, you do not need to write down. You don't need to write down what's under here. All right, this is just an example of direct variation. If a book weighs 3 pounds, then we could say that this is the book's weight varies directly with how many you have. All right, so 0 books weighs 0 pounds. 1 book weighs 3 pounds. 2 books would weigh 6. 3 would weigh 9. And 50 books would weigh 150 pounds. Okay? As one increases, the other one is going to increase at the same rate. Here again is another example of direct variation. If you make $10 an hour, then in 0 hours, you make $0. 1 hour, you make $10 an hour. 2 hours, you make 20. 3 hours, you make 30. And 40 hours, you would make 400. It's a constant increase by 10 per hour, just like the books constantly increase by 3 pounds per book. All right, so two variables x and y vary directly if there's a non-zero number k such that the following is true. These formulas right here, these are going to be extremely important. Please write these down. Y equals kx or k equals y over x. You need to know both of those. You need to know both of those. Now, the number k is what's called the constant of variation. The constant of variation is the number that we were talking about like in the last problem, in the last slide. In the book problem, the constant of variation was 3 because you're constantly increasing by 3 per book. In the money problem, with the wages problem, the constant of variation was 10 because you're constantly increasing by 10. So k is that number, the constant of variation. All right. Just write down these equations. Now, I just want to show you something. Find the constant of variation and the slope of each direct variation model. So here, the constant of variation, going from this point here to this point up here, we had to go up 2 over 1. So the constant of variation is 2. You should also notice that this is also what? The slope. The slope is 2. The constant of variation is 2. Let's try the next one. What do you think the constant of variation is here? Well, the constant of variation in this problem is -1/2. Well, what do you know about the slope? The slope is also -1/2. Notice a pattern? You see how the constant of variation and the slope are equal to each other? Well, ladies and gentlemen, that is not a coincidence. The constant of variation will always equal the slope. Constant of variation and slope are really the same thing. The only reason why they actually name them differently is because constant of variation, if you didn't notice, every time you deal with a direct variation, we always go through what point? In direct variation. In direct variation models, we always go through the origin. In slope-intercept forms, we don't necessarily go through the origin. All right, so this is why I put direct variation after slope-intercept form, because direct variation models are really just the same thing as slope-intercept form models, except direct variation always goes through the origin. So Like I just said, these are the two qualifications of a direct variation. Direct variations have to be a straight line, and they have to go through the origin. Period. Those are the two qualifications for a direct variation graph. They're the same thing as slope, except the y-intercept will always be in a direct variation graph. The y-intercept is always 0 in a direct variation graph. Once again, this is only for direct variation graphs. Because if you have 0 books, it's 0 pounds. If you work 0 hours, you make 0 money. All right, let's graph. This is a direct variation model. Now, graphing these is just like graphing in slope-intercept form. Slope-intercept form, remember, is y equals mx plus b. Well, here, what's b? Well, if it's direct variation, b is always going to be 0. And look, we don't have anything over here. So that's what b is, 0. What's the slope in this problem, or the constant of variation? -3. -3 over what? 1. So, start at our y-intercept. Once again, if it's direct variation, it will be at the origin. And then from there, we're going to make more points using our slope. A rise of -3, a run of +1. Or, once again, we know -3 over 1 is the same thing as +3 over -1. So we could have went up 3, left 1. And lo and behold, this is our direct variation graph. Okay? All right. Now, the variables x and y vary directly. When x equals 5, y equals 20. This says write an equation that relates x and y. Your formulas that I gave you were y equals kx and k equals y over x. Now, you're going to be using these two formulas. This is your main formula. The only thing that I really want when I ask you to write an equation is you having this in the form y equals kx. You just need to find out what k is and then plug it in. Plug it into this formula. This is the main one. All right. However, we use this formula over here to find out what k is. So let's find out what k is. K is what? Well, it's y divided by x. So y in this problem, an example of y and x are 20 and 5. Once again, this is just one example of them. Just like in the book problem, one example of the weights could have been 1 book, 3 pounds. Another example could have been 3 books, 9 pounds. Well, here, an example of the x and y is 5 and 20. So we know that the constant of variation, 20 divided by 5 is 4. I said 5 too many times. So we take that 4 and we just plug it in over here for k. So y equals 4x. This is our formula. All right, you found out what k is by plugging it in. And then we use that value for k and we plug it into y equals kx. Once again, the reason why we don't plug in 20 and 5 in these two positions is because 20 and 5 are what? Examples of one x and y. That's just one x and y that might work. Now, one thing that they also might tell you to do, that I might tell you to do, is find the value of y when x equals 10. Well, guess what? You know that the formula is y equals 4x based on what we did in part A. So now, if we need to find y when x is 10, in other words, they're asking us to find a new value, we can just use that equation that we just made. Y equals 4 times x. Well, in this problem, now they want us to make x 10, so 4 times 10. And we know that 4 times 10 is 40. So when x is 10, y is 40. That's another example. Like 5 and 20 was an example, 10 and 40 is an example. Okay? All right. Try this one on your own. The variables x and y vary directly when x equals 4 and y equals 14. Write an equation that relates x and y. So, again, y equals kx is our main formula. But first, we need to find what k is. Well, remember, k is y divided by x. Well, y in this problem is 14. X in this problem is 4. This is once again one example of the x and y. Always, always, always reduce. So let's reduce that down to 7/2. So we take this, because we know k is 7/2, and we plug it in for the k over here. So y equals kx. That's our formula. Now, I keep mine as improper fractions as opposed to mixed numbers, because if I was to ask you to graph it, remember, k is going to be our slope, so we'd be able to do a rise of 7 and a run of 2, as opposed to 3.5, which, how do you rise that? That's is a little more difficult. Okay. Part B here says find x when y equals 45. Go ahead and pause the video and do that on your own. Alright, so once you've tried that, so once again we have started off with our formula y equals 7/2 x, because we're using that formula from part A. So y equals 7/2 x, and this time they give us y, so y is 45, so we're going to plug that in. 45 equals 7/2 times x. Alright, and then how do you get x by itself? Well, we're going to divide by 7/2, which once again is the same thing as multiplying by the reciprocal, 2/7. And we know that 45 divided by 7/2 is 97. So x equals 97. You may have also had 12 and 12 and 6/7. Alright, so that's an example of another type of x and y. So once again, if x is 14, when x is 4, y is 14, another example would have been when x is 12 and 6/7, y is 45. Alright, here we go. Write down what's bolded in yellow. The income at a store varies directly with the advertising budget. When the owners spent $3,000 per month to advertise, their monthly gross income was $120,000. Write a direct variation model that relates the income with the advertising budget. Now, you probably want to go ahead and pause the video so that everybody can write that down real quick. But after you've done that, here it says income varies directly with advertising budget. The way that you do this problem is the same thing that we did in the last problem. You set up your y equals kx. But instead of y equals kx, we're going to use the variables that are in this problem. Here it says income, so I'll use I. Income varies directly with advertising budget. I'll use B, advertising budget. Alright, so now, this is our direct variation model, our direct variation formula that we're going to be working with. So it says when the owner spent $3,000 to advertise, so that's like our B. That's an example of our B. So if I use this formula up here, so K times 3,000, the income was 120,000. Alright, so when it says write a direct variation equation, we can solve for K. So divide by 3,000. So 120,000 divided by 3,000 is 40. So we get K is 40. So since K is 40, we know our formula could be I equals, our income is going to be 40 times whatever our advertising budget is. So this would be an example of our formula. I equals 40B. Now, using that, if the owners increase, let me kind of just move this up a little bit so I have some room to write. If the owners increase the advertising budget to $5,000 per month, how much gross monthly income can they expect? Well, this was our formula. I equals 40B. So they're saying now, well, instead of the budget being 3,000, we're going to move it up to 5,000. So now they want to know what's the monthly income. Well, 40 times 5,000 is 200,000. So if we have a advertising budget of $5,000, we can expect an income of $200,000. All right, this one, you don't necessarily need to write this one down, but it says tell whether each relationship is direct variation. Well, this is kind of easy. How do you go from y to x? Is there a constant variation? Well, from 1 to 6, what did we multiply by? Multiply by 6. From 3 to 18, multiply by 6. 5 to 30, multiply by 6. Since those all were multiplied by 6, then we can see that the constant of variation was 6, and therefore it is direct variation. In this problem, was there a constant number that we multiplied by to get from x to y? Well, here we multiplied by -1. Here we multiplied by 0, so automatically you can see that this isn't going to work out. So no, because there's no constant of variation. All right, your homework assignment is 4.5 and 4.6 worksheet. Hopefully everybody has a great day and have a good weekend as well.